Hello everyone, this is the second part of the video in which I am going to explain about NDFSM. We already know about this topic, so we'll just go in brief. Okay, now let us know what is NDFSM. NDFSM stands for Non-Deterministic Finite State Machine, right? Or it is also called as NDFA, that is Non-Deterministic Finite Automata. Actually, this non-deterministic finite state machine comes from the word non-determinism, which often looks like a magic. Now, I have shown a diagram of NFA here, which is a non-deterministic finite automata. Let's know some more stuffs about NFA. Okay, listen carefully. Here, in NFA, given the current state, there could be multiple next states. This point says that for a current state, there can be multiple next states in NFA, but as far as we know, in DFA, for one state, there is only one unique next state, right? But in NFA, we can have multiple next states. See, concentrate on the diagram. Assume that A is a current state, okay? Let's check how it behaves on getting certain inputs like 0, 1, etc. Let's check for 0. Okay. A on getting input as 0, it could stay either in A itself or it can even go to C. Are you getting what I am telling? I'll repeat it again. Try to understand. A on getting input 0, it could stay either in A itself or it can even go to C. Okay, similarly, if it gets input as 1, it can go to B or it can go to D. Okay, after understanding this point, obviously we'll get a question in our mind that how do we choose to which state it goes on getting certain input, because it has multiple next states, right? So we have the answer in the next point. So let's move on to the next point. It says that the next state may be chosen randomly, that is, we can choose the next state randomly. Okay, or it says here that all the next states may be chosen in parallel. You can choose the next state parallelly also. Okay, and here you can see something different which we haven't seen in DFA, that is epsilon. So what is this epsilon? Epsilon is actually the empty string. Okay, if you see an epsilon, or if you see that a current state is going to multiple next state on getting the same input, then you should understand that it is NDFA. So this is the method to differentiate between DFA and NDFA, because we are not going to use epsilon in DFA, right? It is a simpler way to differentiate. Okay, let us know about definition of NDFSM. It is a quintuple of K summation delta S and A, where K is a finite set of state, delta is an alphabet, S is an initial state or starting state, A is a set of accepting states, and delta is obviously transition state, right? Now let's move to the next slide. That is, it's very interesting here because we are going to learn about the implementation of NDFSM algorithm in C# language, or it is also called as C# language. It is similar to Java. This language is similar to Java. Okay, let's see the first part of the code. Let me start with something simpler. Okay, that is valid transition. One of the first things is to check the validity of transition, right? Now let us concentrate on the coding part. Here we have used valid transition function which returns q dot contains. See here, q is nothing but k, that is finite set of states. Okay, it says here that q dot contains transition of start state and q dot contains transition of end state, and also it uses sigma which contains the transition of symbol. Through this code, we'll check whether it is a valid transition or not. Now, let us move on to the second part of the code, that is non-deterministic accepts. Like already I have mentioned above that non-determinism looks like a magic, right? This kind of behavior is usually implemented by recursive backtracking. Okay, first of all, we need a method that will start our recursive calls. In non-deterministic automata, we need to do that for all possible transitions from given start state and a symbol. And we should start this from the starting state. In this code, they have used accepts function, which takes string of inputs, and also they have used if statement. If accepts q naught is nothing but a starting state or initial state, comma input new string builder function. If it accepts these things, then it will return as console writer dot success. What is this console writer? Console writer is nothing but the method of console class which is used to retrieve unique objects which is associated with the console. So if it accepts q naught input new string builder function, then it will return as console writer dot success. If the console writer is success, then it will print as trying to accept, or if the console writer is failure or it is failed, then it prints as could not accept the input. Okay. Next, we need to write the recursive function that checks for the sequence of steps that leads from the current state to the final state using specified inputs. So here in this code, a function called bool accepts is used, okay, which has string of current state, input and a build steps. So they have also used if statement. If input dot length is greater than 0, if the length of the input is greater than 0, var transition is equals to get all transition current state comma input. Okay, what is this get all transition? Get all transition is a method which simply goes through all the transitions just to find the transition with specified start state and a symbol. So var transition is equals to get all transitions. We are using a method which checks for the specified start state and a symbol. Okay, get all transitions current state, which takes a current state and the input. And also we have used a for loop for each var transition in transitions. Var current step is equals to new string builder steps dot to string plus transition. If accepts transition dot end state and input of the substring and the current steps, then it will return as true, or else it will return as false. If f dot contains current state, f is nothing but the final state here. If it contains the current state, then the console writer dot success will print as successfully accepted the input. In the final state, we will have the current state with the steps. Then it will return as true, or else it will return as false. So let us move to the last part of the code, in which they have used IEnumerable. What is this IEnumerable? IEnumerable is an interface that defines one method in a C# language. It is an interface that defines one method. So in this code, it has defined the getAllTransition method. Okay, let us go according to the code. Private IEnumerable transition get all transitions, in which it takes the string of current state and the char symbol, that is characters of a symbol, and then it will return as delta dot find all, in which t is nothing but t dot start state is equals to current state and t dot symbol is equal to symbol. So this was the last part of the code. Now let's come to the conclusion that The difference between DFSM and NDFSM is quite small, but their algorithms are quite different because the method of reading the input in the case of DFSM proceeds in a linear fashion, but whereas in NDFSM we should read all the input but not finish in the end state and then backtrack back to the beginning with whole input left to read. So this makes the NDFSM algorithm perform much slower. Okay, so that's what I wanted to share with you guys. Hope you have understood. Have a nice day. Thank you. Hello everyone. This is the second part of the video.